Okay, this is me going through the C1 January 2014 paper. The best advice I can give you is to pause this video before I attempt questions and see if you've got the right answer as I'm going through it, okay? By all means, fast forward what I'm saying, etc, etc. But this is a really personal way to practice before the exam. So I'll do one today and I'll do one before the exam on Wednesday. Okay, so first question, it says the points A and B have these coordinates respectively. The line L1 passes through B and is perpendicular to AB. Find the gradient of AB. So this is one of the key formulas that we've learned. We've learned it as dy over dx, meaning the difference in y's divided by the difference in x's. So if I'm to do the difference in y's, that's going to be 1 minus minus 2. So be careful with this. You've got to be very careful with your negatives here. So 1 minus minus 2. And because I did 1 first, I have to do 4 first. So that is 4 minus 6. This would give me positive 3 over minus 2, which is minus 3 over 2. Okay, fine to say minus 1.5 if you want to do it instead. And that is the gradient of AB. And I'm just going to try and annotate my work as I go so it's obvious what I'm doing. So minus 3 over 2. It then says find the equation of L. So that was part 1. This would now be part 2. So we've learned a formula which is as follows: y minus y1 equals mx minus x1, and we sub in either A or B's coordinates because, no we don't, because it says L1 passes through B. Can you see that by there? So it passes through B, so we can only sub in B's coordinates. B's coordinates are the ones I would have preferred to have done anyway, because they're both positive, but I have to sub in B's coordinates. L1 passes through B. It is perpendicular to AB. Okay, so because it's perpendicular to AB, that's what it says there, it means we need to work out what L1 grad is. So the L1 gradient would be equal to 2/3 as minus 3 over 2 times 2 over 3 equals minus 1, and that is what we call the condition for perpendicular lines. Okay. So important these things don't pop up out of nowhere. Condition for perpendicular lines. So when I'm subbing into this, M, that is this is M. And then I've got to sub in B's coordinates. So B's coordinates were 4, 1, so that is y minus 1 is equal to 2/3, and then that'd be x minus 4. I don't like this 2/3, so I'm going to times this side by the 3 instead. So I get 3y minus 3 is equal to 2x minus 8. And we tend to get that in the form y and x is all on one side rather than getting y equals mx plus c, purely because the y has a gradient and it will make it look quite messy. I tend to keep the x positive. It doesn't matter though, you can have it round the other way if you like. So that means I'm moving everything over and I get the answer 2x minus 3y minus 5 because that minus 3 was added onto the minus 8. Okay, so 5 marks so far. Part B says L2 passes through A and it has that equation. The lines L1 and L2 intersect at point C. Show that C has the coordinates minus 2, minus 3. Now this is going to be really nice because I'm given that formula there. I know this one here because I've just worked it out. If I don't get the answer minus 2, minus 3, then I've done something wrong up here that I'll have to go back and go and check my working. So part B then. I'm going to write out the formula that I'm given there. I'm told that x minus 8y minus 22 equals 0. And then I'm going to put in brackets L2 equation. That's what we're given. This was the L1 equation. And where two lines cross, that is simultaneous equations. I'm going to rearrange, personally, to x is equal to 8y plus 22. I'm going to call that equation 1. I'm going to call this thing here equation 2. And I'm going to sub 1 into 2. So, what do I get? Well, wherever I see an x, I'm going to change to 8y plus 22. So that is 0 equals 2, and then I'm going to change that to 8y plus 22, minus 3y, minus 5. So 0 is equal to 16y plus 44, minus 3y, and then minus 5. That comes to 0 is equal to 13y, and then plus 39. So minus 39 is equal to 13y, so minus 3 is equal to y. Now that's really good news. Sorry, just so you can see what I'm doing with the camera. That's really good news because my y coordinate there is -3. So yes, that's right so far. So then I'm going to sub y equals -3 in 1, this thing here. And I'm going to get x is equal to 8 lots of -3 plus 22. So x is equal to -24 plus 22. So x is equal to -2. Therefore, C is -2 minus 3 as required. So that's part 1 done. Part 2 says, find the coordinates of the midpoint of AC. So I know A's coordinates, in fact I'm going to write them down. I'll try and move the camera a bit there, there we go. A's coordinates were 6, -2. C's coordinates were, we just worked them out, -2, -3. So I want to know the midpoint. So the formula we use for that is x1 add x2 all over 2, and then y1 add y2 all over 2. They're my coordinates. So I would do the x coordinates add each other, so that would be 6 add -2 over 2, and it would be -2 add -3 over 2, which would give me 4. 4 divided by 2 is 2. And then this would give me -2 add -3 would be -5, divided by 2 would be -2.5. Okay, and think about it, it should be in the middle of -2 and -3. Yeah, -2.5. In the middle of 6 and -2, that's a difference of 8. So yeah, 4 each way, yeah, that does make sense to me. Finally, it says, find the area of the triangle ABC, simplifying your answer. Okay, so A's coordinates, C's coordinates, and B's coordinates. And what I'm going to do for this bit, I'm going to try and sketch it because I think that'll make a bit more sense. Now, I tend to not really draw the axes if I can help it because I think it just makes it too complicated. So if A was 6, 2, so let's say this is the origin, 6 minus 2, that would be A. So that is 6 minus 2. C then would be -2 minus 3. So -2 minus 3 there. And then B was 4, 1. So somewhere up here. And then 4, 1. Just roughly about there. You know, it doesn't have to be perfect. 4, 1. Okay? So it's something like that. Now, I've got to try and work out some stuff here. We're told that AB... right, we're told that the lines... What are we told here? Let's try and get our heads around what's going on. We're told that the line L1 passes through B and was perpendicular to point to AB. So that must mean a right angle there. Okay, so that was my line L1. They cross, the two lines crossed, so this was L2 by here, and they crossed at C. That's what we were told by here. It says the lines L1 and L2 intersect at the point C. So in order to work that out, I need to do a half base times height, but I need to use the right angle. Now the right angle's here, so the base would be the distance of AB, and then the height would be the distance to B to C. Okay, so from B to C would be the square root of the difference in x's adds the difference in y's, which is basically Pythagoras' theorem. So if I'm on -2 here, and I go up to 4, that's going to be a difference of 6, plus, if I'm on -3 and I go to 1, that'll be a difference of 4. So BC would be 6 squared plus 52, 6 squared plus 4 squared, sort of answering the question as I'm going here, which is 36 add 16, which is root 52. And then I need to do the same for A to B. So 4 to 6 is a difference of 2, 2 squared plus, and then -2 to 1 is a distance of 3, so 3 squared. So AB is equal to root of 4 plus 9, so AB is equal to root 13. So the area of the triangle would be a half base times height, so area would be a half of the base, which I'm going to call AB, which is root 13, so times by root 13, times by root 52. Now, that's probably going to cancel down, and the hint that I know is going to cancel down is simplifying your answer. To simplify my answer, I'm thinking 13 times by that. Does 13 go into that? So 13, 26, and double 26 is indeed 52. So that would be root 13, half root 13 times by root 13 times by root of 4. The root of 4 is 2. A half of 2 will cancel. So a half and the root 4 cancel. Then root 13 times root 13 is 13 units squared. Okay, now the one thing I will tell you now, I haven't looked at the answers to this paper. I'm trying to have a look at this blind to put you in the same position, or to put myself in the same position you will be in on Wednesday. That does mean I might make the odd mistake. Usually if you get an answer like that, I would have felt pretty confident, but you may have a different answer to me. You may be right, I may be wrong. You know, it's Sunday, I'm having a lovely cup of tea now watching this video. I may be wrong, I'm not promising to be right on absolutely everything. Okay, right then, over the page then. We are going to do question 2, which is going to be the third question. Just move the camera up a bit. Okay, and question 2 looks pretty straightforward. These are sort of questions we should be used to. So we've got 3 root 3 minus 2 root 5 all over 2 root 3 plus root 5. Okay, now the way that we do this is we always times top and bottom by nearly exactly the same thing as the bottom, but whatever that sign is there, this is always the opposite. So minus is going in there, and then 2 root 3 minus that. And then this is equal because whatever you do to the top, if you do to the bottom, it's an equivalent fraction. Okay, now that means I need brackets around the front bit, and I need to extend this line here. Okay, so I'm going to get 3 root 3 times 2 root 3 is going to be 3 times 2 is 6. Root 3 times root 3 is going to be just 3. So I'm going to say it's 6 times 3. You can go straight to 18 if you're confident enough, but by all means take your time like I am. 3 root 3 times minus 5 would be minus 3 root 15. Minus 2 root 5 times by 2 root 3 would be minus 4 root 15. And then minus 2 root 5 times root 5 would be plus 2 times 5. The 2 root 5s will cancel, just being 5. And then on the bottom, we're going to get 2 root 3 times 2 root 3, so that is going to be 4 times 3. Now you're going to get 2 root 3 times by minus root 5, and then plus root 5 times by plus 2 root 3, so they're going to cancel. So I'm just not even going to bother writing them down. In the exam, probably a good idea to write it down, show that you understand that they cancel, but well, let me stop being so lazy actually. I should be doing what you're doing in the exam now, okay? So it's plus 2 root 15, minus 2 root 15, and then we're going to get a minus 5 as well. So those two cancel. So this is how you simplify a third, okay? And then 6 times 3 is 18, and then I'm going to get minus 3 root 15 minus 4 root is minus 7 root 15, and then I want a plus 10 onto that, all over 4 times 3, which is 12, take away 5. So that is then going to give me 28 minus 7 root 15 all over 7, which is very good news for me because 7 goes into that, 7 goes into that. So it's a massive indication that I think I'm right. So it's 4 minus root 15. Okay, and then for part B, oh, there is no part B. That's a shame. We like thirds, so we'd like to have 8 marks possibly come up. Okay, in question 3. So it says the curve has a tangent y equals 20 over x, so I can tell you now we're going to have to rewrite that in a second. 20 over x plus 2x squared minus 11. The point P has coordinates 2, 7 and lies on C. Find the equation of the normal. They put that in bold. That's obviously massively important. At C, 2C at P. Okay. Pause the video, have a quick think about how to do it. I've just done that now, have my sip of tea. I'm going to take the y out of having the x over. You need to have that as 20x to minus 1 because then you can't differentiate it. I'm going to differentiate so I can find the gradient at this x value of 2. Whatever that answer is, that will be the answer to the tangent, not the normal. So then I need to times that by minus 1, or have it so the two gradients will times together to be minus 1. Okay, so that's going to take me a little while. I'm going to do that straight away. So I'm going to write it out as 20x to the minus 1, and then plus 2x squared minus 11. So dy by dx, so by differentiating, dy by dx means finding the gradient of the tangent. I'm going to get minus 20x to the minus 2 plus 4x to the 1, I suppose, but I'll leave that just plus 4x. Then I'm going to say at x equals 2. It told me 2, 7, but the x coordinate was 2, the y coordinate was 7. That's y is not in this at all, so I'm not interested in it. Say dy by dx. Now I'm going to rewrite this as a minus 20 over x squared. So that's going to be over 2 squared. And then plus 4 times 2. That is minus 20 divided by 4, which would be minus 5, plus 8, which would eventually be 3. Okay, so I'll say dy by dx equals, and I'll put in brackets, gradient of tangent. Okay, therefore, grad normal equals minus 1/3. Okay, and that's because minus 1/3 times by 3 equals minus 1, condition for perpendicular lines. Find the equation of the normal. I now know its gradient. I know the coordinates to go through are 2 and 7. Just make sure you sub them in the right way. So it's going to y minus y1, so that would be y minus 7 is equal to minus 1/3 x minus 2. Okay? Times the 3 both sides, so I'm going to get 3y minus 21 is equal to minus x plus 2. Very easy to accidentally not get a plus there, but a minus times a minus is a plus. And then I want x to be positive, so I'm leaving nothing on this side and bringing everything else over. So I'm going to x plus 3y minus 23 equals 0. Okay, and that is question 3 done. Okay, question 4. Okay, so it's telling us the form we want it in. We want it to look like this thing here. So a bit of a hint to get us started. Number 4. So it says x squared plus 1.6x minus 24.36, and then it says maybe expressed in this form. Okay, so to complete the square, we always have this coefficient here, so 0.8, and we remove the x from it, and we remove the squared from there, put it out there, which would give me x squared plus 1.6x, but it would also give me whatever this is squared. I don't want that. I need to get rid of that. It's minus 0.64, and then also minus 24.36, and then I can rearrange that, or I can simplify the terms here to be minus 25. Okay, so it's in the form that they wanted now. It then says, hence solve the quadratic equation, this thing, x plus 0.8 squared equal to 0. Now, I've taken a bit of a jump here. I put that equal to 0 because that is that which I've just written in that form. Okay, it makes things a lot easier to solve when you've got it in complete the square form. Okay, so really when it said x squared plus 1.6x minus 24.36 equals 0, I've gone and changed that to that straight away to make it easier. Okay, so what I'm going to do now is take the minus 25 over and take it over to the other side. Now that's good because we want to have a square number here because this thing here in brackets is squared. So when I get rid of the squared, I'm going to square root. Now be very careful here. When you square root, what happens? You get plus or minus the square root of 25. So x plus 0.8 is equal to plus or minus 5. Okay, whenever you get a quadratic, you always get 2 solutions. So I could say x plus 0.8 equals minus 5, or x plus 0.8 is equal to 5. So then taking minus 0.8 off each side, I get x equals minus 5.8, or x equals 4.2. Okay, so there's my 2 solutions. Question 5. Okay, so they want me to write surds in this paper. The surds coming up again now for question 5. Okay, then it says use the binomial theorem to express 1 plus root 6 to the power of 5 in the form a plus b root 6, where a and b are integers whose values are to be found. And then you can see for part B, I've already written something out there from the formula booklet. You'll just have that easily at hand. I've written it on this just so I didn't have to go and look for it now. Okay, so 5a. Right then, so 1 plus root 6 to the power of 5. Now because this is to the power of 5, I know the power, I'm going to start writing out Pascal's triangle. I'm going to cheat and go straight to a line that I know off the top of my head, which is 1, 4, 6, 4, 1. I know that's right, but if you need to generate more than that, feel free. 1, 5, 10, 10, 5, 1. That's the line I'm interested in. So it then says, express that thing in that. Okay, so whatever these coefficients are now, it is going to be 1 plus 5 plus 10. Now you can see I'm spacing this out loads because I'm going to write a load of stuff after. Okay, if you try and cram everything together, you'll probably mess this up. Okay, so it's a good idea to space your working out. Now in some respects, I don't need to do this. I am going to do it just to show you what's really happening. But 1 to any power, I make a mistake here. 1 to any power is always going to be 1. Now this number here, this power, should be descending by 1 each time. So that should have been to the power 4. This should have been to the power of 3. So 1, 1, and then 1 in there. That should go 2, 1, 0. Okay. Now alternatively, not alternatively, doesn't work. Respectively, I don't know what the word is I'm looking for here, but the other way around, the root 6 is going to rise, going from the power of 0 up all the way to the power of 5. Okay. So root 6 squared. Now it's very important you get all of these in. 6, root 6. So I got up to squared, so then this one's got to be cubed, this one's got to be to the power of 4, and this one's got to be to the power of 5. And you should notice that the powers in each stage, 4 add 1 makes 5, 3 add 2 makes 5, 0 add 5 makes 5. Okay, it's not a coincidence they're doing that on purpose. Now, from here, I know 1 to any power will always be 1, so I'm totally disregarding this when I think about it, and anything to the power of 0 is always 1, so the first term will just be 1. Okay, the next one is going to be 5 times 1 times by root 6, which is 5 root 6. The next one is going to be 10 times root 6 squared will be root 6 times root 6, which is 6, so this would be just plus 60. Root 6 cubed will be root 6 times root 6 times root 6, which will be 6 root 6, times that by 10 will be 60 root 6. And then this will be root 6 times root 6 and so on, so it'll be 6 from root 6 times root 6, then times by 6 again, which is 36. 36 times 5, don't know. 36 times 10 is 360, so it must be half of that because 5 is half of 10. So that would be 180. And then root 6 to the power of 5 would be plus 36 root 6. Okay? And then to simplify that, I just need to get all the root 6 terms together. I need to get all the number terms together. So 180 plus 60 is 240, plus the 1 is 241, plus 65, maybe the easier way to do this, 96 add 5 is 101, so 101 root 6. Okay, so that's part A done. Part B now, I'll have to look at the question again. Okay, so it says the coefficient of x squared. Okay, so this is the term I'm interested in particular out of my formula booklet, just this bit here. Now, I've got to be very careful. This thing here is not that thing there. This says 1 plus x. I've got 1 plus 3x. I can use this providing I say let x equal 3x. Okay? So I'm going to start off by saying that let x equal 3x. So 1 plus x, the n coefficient. The coefficient, I'm only going to write down the one I've circled from above because that's the only one I'm interested in. Would be n times by n minus 1 times by not x squared. We've just said x is 3x, so that's got to be 3x squared there. Very easy to accidentally forget that. I've done it before in one of these videos. And then 1 dot 2 means 1 times 2, which is just 2. Okay? Now, that is going to give me, I'm going to say dot 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 before, plus, and then plus dot 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 to show that there were other terms, but I'm interested in that because it says, what's it say? It says the coefficient of x squared is 495. So once I get the coefficient, I just need to put that equal to 495 and solve it. So therefore, 3x squared is going to give me 9x squared. So 3x all squared gives me 9x squared. Okay, I'm going to bring that 9 to the front. N times by n minus 1 all over 2 is equal to, I've got rid of the x squared now because I'm only interested in coefficients, so that's why the x squared has disappeared, is equal to 495. Why 495? Because they told me it's 495. Okay, so I'm going to bring the 2 over here. which is going to give me 9n n minus 1 is equal to 990. And then I'm obviously going to divide both sides by 9, which is going to give me 110. Now at the same time, just because I'm running out of room, I'm going to expand the bracket to n squared minus n, and I'm going to bring over the 110 I've just said that this is going to give, and get that equal to minus 110 is equal to 0. That's just a quadratic now I need to solve. And to solve that, I need to think of a pair of numbers that times to 110 and add up to minus 1, and that'll be minus 11 and plus 10. Okay, if you ever get some nasty numbers there, like 110 is not the nicest number, but it's probably going to be quite obvious, so like try and think of the obvious numbers to make it, okay? Okay, so the answers are n equals 11 or n equals minus 10. If I read the question again, it says, given that n is a positive integer, that means this is my solution. Okay, so I'd say as n is a positive integer, as n is bigger than 0 then. Okay, right, that is question 5 all done. So question 6 now. Question 6. So it says brackets 2k minus 3x squared, and then it says plus 8x, and then they very kindly put the next bit in brackets for us as well, because that'll make things easier now when I do what I need to do. Now, I looked at that and I started to worry. It's like, what on earth are they talking about? Show that k satisfies this m minus nk squared. Just totally ignore it. Pretend it's not there. Okay? What will we normally do in this form? It says no real roots, so b squared minus 4ac must be less than 0. And then I'd sub in my a's, b's and c's. Let's just do that and see what we get, okay? So, a equals, b equals, c equals. So this is in the form ax squared plus bx plus c equals 0. If you didn't know that, you know, I wouldn't say you're going to do very well on Wednesday. You really do need to hit the books if you're unsure why that's the case. 2k minus 3, and then this is 8, and then this would be 2k plus 3. But they may well not put that in brackets, and they may even not put that equal to 0, and you may have to make it equal to 0. We've seen that recently in our Einstein questions. B squared minus 4ac is less than 0. Maybe an idea to say no real roots. You know, annotate your work. Why are you doing that? Especially if you've got time at the end, just say why you did things. You could get marked for that if you mess something up later down the line. So that would be 8 squared minus 4 brackets 2k minus 3 and then 2k plus 3 is less than 0. Okay, so that's going to give me 64 minus, don't do anything with the 4 yet, leave it there for a second. Okay, 2k times 2k would give me 4k squared. 2k times plus 3 would give me plus 6k. I then get a minus 6k from this side here doing it that way, and then I get a minus 9 there. Okay, and then I'm going to get 64 minus, now be very careful here, so I'm going to put a line through there to show they cancel. I'm going to get minus 16k squared, and then I'm going to get minus 4 times minus 9 is plus 36, is less than 0. So then I'm going to get 64 minus 16k squared. So that is going to be 100 minus 16k squared is less than 0. Okay, now what do they want me to do here? It says, show that it is m minus n. Yeah, we've done that, okay? That's what I've done there. Where it says that, m was 100 in my case, minus n being 16. And it says, where m and n are integers whose values are to be found. Okay, so to solve this bit then, what I'm going to do is I'm going to take over the minus 16k squared. It certainly shouldn't be minus anymore because I'm just taking it over to the other side. I'm then going to divide both sides by 16. I'm going to take 16 over and get it's less than k squared there. I'm pretty happy with this next bit because that's squared. I can square root those individually. And then I'm going to get 10 over 4 is less than k, and then I'm going to get 5, and I've made a mistake, okay, we'll see if you spotted it in a second. 5 is less than that. Okay. Now, where I made my mistake was here, I believe. Okay, when I took that over, really what I should have done, say correction question mark. I feel like I've made a mistake here. Okay, we've got. I don't like the k being on this side. I'm used to having it this other side, so I'm going to change those around. But if I change those around, I've got to flip the inequality as well. Okay, and then I'm going to bring this over as k, but what happens when you square root something? Well, you get plus or minus that answer, okay? So that would be over that, which is then, the rest of it then, you know, would seem fine. But I get two answers, and it doesn't make sense that I can have it's bigger than plus or minus 5 over 2. Okay, so what it is, I believe, is that k would be less than minus 5 over 2, or k would be greater than the 5 over 2, because that minus flips the inequality. It's something to do with that. Okay, I've gone blank off the top of my head, being on camera, exactly how to explain it, but it's because you get the squared giving you two, giving you two answers, like in its parabola. So I think we find that we've got these two solutions. So this is 5 over 2, and this is minus 5 over 2. And they wanted where we're greater than 0, which was this bit here, but it was also this bit here. So this is k greater than 5 over 2, and this is k is less than 5 over 2, gives those two answers. Okay, so yeah, we've done the parabola before. I'm hoping that's made a bit more sense now I've drawn the graph. We've seen it like this plenty of times throughout the course. Okay, question 7. Okay. So question 7 is a question on transformation of graphs. First bit pretty easy, 3 marks as well. Second bit slightly different just because they've worded it slightly different, okay? But let's get the first mark sorted. We can easily get these squeezed in by here. So 7a, and then it would be that to there. Okay, now, they had a graph that looked like that. And then minus 3, if it is inside, it is doing the opposite of what you expect to the x coordinate. So instead of moving 3 down this way, it's actually moving 3 up this way. Okay, so now instead of going through minus 4, it's going to go through minus 1. Instead of that stationary point being 2, 6, it's now going to be 5, 6, and this will be 11. Okay, so when I draw that, it's got to look, you know, relatively correct. That's certainly got to be going through the negative axes. So I would say by here, minus 1, 0, this would be 11, 0, and this stationary value here would have been 5, 6. Part B. It says, for part B, it says that figure 2 shows a sketch of the graph having one of the following equations with an appropriate value for Q, PQ, or R. Okay, right. It can't be f of x plus p. Plus p would suggest the graph has moved up. And I can see there that it's still going through 0 and 0, and it's still going through 6. That definitely hasn't moved there through that, so we can discount that one. Now, qx, when that happens, when you've got q inside, what it does is it starts to squeeze the graph, and that graph definitely has been squoze, isn't it, if you like. So, that 8 has gone to 4. Now, if I did that, I've divided that by 4. Okay, minus 4 divided by 4 would be minus 1, but this has remained exactly the same, so it's not that. That's not true either, because otherwise it would have had to have happened to both of them. Okay, now Rx there would be a case that you could still squeeze it, but, oh hang on, what's going on with my computer? Second, there we go. But if that's the case, it will have been that it will be a minus number because it will have reflected it in the axes. So I believe, oh hang on. Right, no, I think I disagree now. That has been reflected, as far as I'm concerned, this has been reflected in the y-axis, that 2, 6, but it's become minus 1, 6. And this minus 4 is a property to do with that 8, 0. So I think it's been flipped in the y-axis and then squeezed. So I disagree. I think that's right. I think that's wrong, because that would have stretched all the values like that, and we've already said that's not happened. So to flip it, I've got to have had a minus number, and then that 8 has gone down to a 4, That 4 has been halved to come to a 2, and that 2 has been halved to become -1 once it's been flipped. So the answer is, for this one here, for part B, it would be y equals f of qx, where q is equal to -2. Okay, so the minus did the y-axis reflection, or the y-axis flip, and then the 2 halved the values. Okay, sneaky one that's not the easiest one we've ever seen. And on to the last page now. We've probably got a few of the more challenging questions. So, it's not the longest paper in the world. So question 8, first principles. I will go through the first principles because I've not done that for ages, but you should know this off by heart by now. So y is equal to 7x squared minus 6x minus 3. Okay, I'm going to try and do this ultra quick. We add y and a little bit of y. And because we've added a little bit of y, that means we'll have to add a little bit of x. And we call a little bit of x and a little bit of y, we call that delta y and delta x. Okay, the first thing they give us we call equation 1. The second thing we call equation 2. And you must expand what this is. Now, I know that x squared plus delta x, I already know that becomes x squared plus 2x delta x plus delta x all squared. Okay, I'm then going to times that by 7, so I'm doing that in my head ultra or pretty quick. So 7x squared plus 14x delta x plus 7 delta x all squared minus 6x minus 6 delta x, that's me expanding this bit here, and then minus 3. To then do differentiation, you find the difference in y's divided by the difference in x's. So the difference in y's, y plus delta y minus y. So basically, the y's will cancel. Basically, anything that you see in this first equation here will cancel out of that one. So 7x squared is in both, minus 6 is in both, or minus 6x in both, and minus 3 is in both. So I get the statement delta y is equal to 14x delta x plus 7 delta x all squared minus 6 delta x. Anything you notice on this side here, yes, they all have delta x in them. So let's divide both sides by delta x. So that would be delta y divided by delta x is equal to 14x plus 7, just delta x now because the squared is going to cancel by a power, minus 6. I would then say dy by dx exists as lim delta x, that tiny little bit of x tends towards 0 of delta y over delta x. So basically, wherever you see a delta x, change it to 0. 7 times 0 is 0. Leave me with dy by dx is equal to 14x minus 6. Okay, that's me doing that from first principles. Part B, it says y equals ax to the 4/3 plus 24x to the half. That's common. They could have given you that as square root of x. And dy by dx is equal to 11 over 2 when x is 64. Find the value of the constant a. Okay, then pause the video, have a quick think about how to do that. Okay, I've just finished my tea, so no more tea breaks for me. Okay, so what you do is you differentiate it as you normally would, so times by the power. So that would become, just make that focus a bit better. Okay, that would become 4/3 a x to the 1/3 plus a half times by 24, so that would be 12x to the minus a half. Okay, now that is an a. It looks a little bit like a 9. Just be wary of that. We're told that dy by dx is 11 over 2 when x is 64. So before I do that, actually, to make things easier, I'm going to rewrite this as 4/3 a to the cube root of x plus 12 over the square root of x. Okay, now I'm going to sub in those values. So 11 over 2 is equal to 4/3 a times by the cube root of 64, and then plus 12 over the square root of 64. So the reason why they chose 64 is that it can be cube rooted and square rooted and give nice numbers. So 11 over 2 is equal to, okay, cube root of 64 is 4. 4 times 4 is 16 over 3a. Plus 12 over 8. Best thing to do now is get them all over the same denominator. Let's make that 24. So times by 12, so 11 times 12 is 132. Times that by 8, 8 times 16, 8 times 8 is 64, times that by 2 is 128a, and then that's times by 3, so that would be 36. So I would have 36 coming off this side here, would give me 90 and 96 over 24 is equal to 128a over 24. They're both over 24, so times both sides by 24 just cancels both the 24s. So then a is equal to 96 over 128. Halve each of those will give me 48 over 64, and then halve both those is 24 over 32, which then you can divide both by 8, so that is 3/4. So a would have been equal to 3/4. Okay, so I'll make that stand out a bit more here. A equals 3/4. Okay, question 9. 9a, so it says, let me move the camera up a bit better, there we go, question 9a says ax cubed, I'll write this at the top, plus 13x squared minus 10x minus 24 is divided by x plus 3 and the remainder is minus 39. So I can say f of minus 3, and then I will sub into that, so a minus 3 cubed plus 13 lots of minus 3 squared minus 10 lots of minus 3 minus 24 has a remainder, so that's equal to minus 39. So I'm subbing that in there. I would get minus 27a. I would get plus, because the minus is going to cancel out in a second. 3 times 3 is 9. 13 times by 9. 13 times 10 is 130, and then take away 13 would be plus 117. Minus 10 times by minus 3 would be plus 30, and then minus 24 is equal to minus 39 there. That's really just plus 6, so that would be minus 27a plus 123 equals minus 39. So now I'm going to move over the minus 39 and take the 27 over here, so 27a now becomes positive. Add 40, take away 1 would be 162. 162 divided by 27 is equal to a. Obvious numbers that go into 27 are 9 and 3, so let's divide by 3, so that's going to be over 9. 3's into 15 is 5 with 1 remainder. 54 divided by 9 is equal to a, and then 6 is equal to a. There we go, that's what they wanted. Okay, I've done that pretty quickly. If you're wondering how I was doing any of that, ask me in lesson tomorrow. And then says solve the equation. So now I've got to solve 6x cubed plus 13x squared minus 10x minus 24. Now they've been a bit mean here. They've given us an answer before which had a remainder. So because it had a remainder, I don't know it's a factor, so I need to go and find a factor. So I'm just going to write down a couple. If we get it first time, great. If we don't, it's part and parcel, unfortunately. I'm hoping it'll be one of these four here. So 6 lots of 1 cubed plus 13 lots of 1 squared minus 10 minus 24. Okay, so 6 plus 13 is 19. That's clearly not going to equal 0. What about when it was minus? So 6 lots of minus 1 cubed plus 13 lots of minus 1 squared minus 10 times by minus 1. Well, this might work. That's going to be minus 6. That's going to be 13. That's going to be 13. That's going to be plus 10. So that's going to be 23. No, I don't think that's going to be 0 either. Okay, then so 6 lots of 2 cubed plus 13 lots of 2 squared minus 10 lots of 2 minus 24. So that's going to give me 8. That's going to give me 48. And then it's going to give me plus 13 times 2, 26, 54. And then it's going to give me minus 20. And it's going to give me minus 24. So that's quite clearly not 0 either. Just check I've written it down correctly. Yeah. Minus 10, yeah. Okay, let's try the minus 2. 6 lots of minus 2 cubed plus 13 lots of minus 2 squared, minus 10 lots of minus 2, minus 24. Okay, so that's going to give me minus 48 this time. It's going to still give me plus 54, and then it's going to give me minus 20. No, it's not. It's going to be plus 20, and then it's going to give me minus 24. That's not 54, it's 52. That still wouldn't have made any difference up here. That's good news. I think this is it. Yeah. 52 plus 20, so these two make plus 72, and then minus 48 minus 24 is minus 72, so that equals 0. Therefore, x plus 2 is a factor. Okay? You can see how easily it would have been, though, for me to have accidentally missed that, so just take your time. You know, I'm rushing here because it's Sunday and I want to go out and do a few things, okay? In the exam, take your time, don't rush it. Okay, so x plus 2 is a factor. Am I making this equal to 0? Yes, I am making it equal to 0, which means I need to know all the x values. I can't just factorise it. Okay, now I have 6x cubed here. So this must be 6x squared, because x plus 6x squared makes the 6x cubed. If you're unsure on that, go and look at my video. I've got one on here about how to do the factor remaining theorem. Minus 24 here. I've got plus 2 there, so this must be minus 12, because 2 times by minus 12 is minus 24 up there. Okay? Now, I'm going to make plus 13x squared from there. I've already got plus 13, no, I haven't got plus 12x squared there from 2 times 6x squared. Now, this is going to be an x term. So that's going to give me something x squared. How much, I don't know. So I'll put a question mark there, and I've got to make 13x squared from what I circled above. So this must be 1. So x times by just plus 1x plus x is the answer there, okay? So that's my answer, just plus 1x if you wanted to. We're usually getting that to like 4 or something like that, but that's been quite nice for once. And then we've got to factorise it. So 6 times by minus 12 is minus 72, and they add up to plus 1. I already know that, just it came to me very quickly. Minus 8 and plus 9. So I'm now going to get x plus 2, and then 6x plus 9, and then 6x minus 8 equals 0. Not fully factorised yet. If you do this method, you must fully factorise, which would be 2x plus 3, and this would be half is 3x minus 4. So x equals minus 2, x equals minus 3 over 2, and then x equals 4/3 would be my answers for 9 part B. So there we go, that was part B there. And final question now. We've been doing a lot of optimization, so it's nice to have a break from optimization for once. We had optimization in WJEC's paper last year, so we're sort of expecting it not to be optimization this year. So let's make sure we know how to do this, okay? So for question 10, it says y is equal to minus 2x cubed plus 12x squared minus 18x plus 5. Okay, find the coordinates and the nature of the stationary points. So pretty standard start of this. Okay, so stationary points is when the gradient is 0, so we differentiate to get minus 6x squared plus 24x minus 18. We put that equal to 0 for stationary points. And I don't like this minus in front of the x squared, so I'm going to divide through by a minus, but also I can see 6 goes into each of these. So I'm going to divide through by minus 6. So that's going to give me 0 is equal to x squared minus, now it will change these, their opposite signs. So minus 4x and then plus 3. So 0 is equal to x minus 3 and x minus 1, because they add up to minus 4 and times to plus 3. So x equals 3, y is equal to minus 2, 3 cubed plus 12 lots of 3 squared minus 18 lots of 3 plus 5. Okay, a bit of a pain this one, but we've got to get through it. 3 cubed is 27, times by minus 2 is minus 54. And then that is going to be 9. 9 times 12 is 108, I hope. Minus 54. Oh, that's quite nice, because minus 54 is going to cancel there, plus 5. So y is equal to 5, so that's my first set of coordinates, 3, 5. And when x is equal to 1, y is equal to minus 1 cubed plus 12 lots of 1 squared minus 18 lots of 1 plus 5, which is equal to minus 2 plus 12 minus 18 plus 5. Get the pluses together, we get plus 17, take away 20 is minus 3. Okay, I hope anyway. So then my other set of coordinates would be 1 minus 3. Now to determine the nature of these points, I'm going to d2y by dx squared. Now make sure you're doing that from the dy by dx, not from where I divided it by minus 6. That'd be wrong to be doing it from there. It's got to be this one here. So that would be minus 12x plus 24. And when x equals 1, d2y by dx squared would equal minus 1. Sorry, you can't see what I'm doing here, can you? Okay, would equal 12 times by, oh sorry, minus 12 times by 1 is minus 12 plus 24 is equal to 12, which is greater than 0. Therefore, that is a min, not a max like you'd assume. And when x is equal to 3, d2y by dx squared is equal to, it's going to be minus 36 plus 24 is minus 12. Now that's great news because they're sort of like the opposites of each other. So we've seen that as we've gone through the lessons, that if we get that, we feel pretty confident. And if that's less than 0, therefore it's a max. Okay, so there you go, I proved the nature of those points there. And it says sketch the graph for part B. So for part B, get your axes. Now, first thing I've been moaning at you all to do, look at what it says here. The term without x is plus 5 is going through plus 5 then. Okay, so I know the y-intercept is plus 5. Coordinates 1 minus 3. So 1 minus 3 would be about here roughly. 1 minus 3. And then the other one, 3, 5. So 3, 5. It's actually in line with that one before, isn't it? 3, 5. There. So the 3, 5, when 3 went in, it was a max. So it's doing this, coming down like that. And then 1, when 1 went in, that was a min. So it's coming like that. But then this is really important that it goes up, up, up through that value there and that value there being 5. Okay, so that's what the graph would look like. And then finally, last bit of the entire paper says, given that it has 3 distinct real roots. Okay, hold your pen horizontal to the page. Get your pen, where does it cross that graph? 3 times. Here it's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Finally, 2 times. Dead there on 2 on 5. Now less than 5, so when it is less than here, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, back to 2. So 3 when it's bigger than this value here. Okay, now it says it has 3 distinct real roots. So it is when k is less than the 5, when it's less than, it's always the y coordinates for this bit, and when k is greater than minus 3. Now, are those 2 arrows pointing at each other? Yes, then that means I can write that as one continuous inequality. So I flip over the minus 3 and the k, but that means I flip over the inequality. And then I'm basically picking up this inequality and plonking on top of it. So that k matches up with the k. I'm told that k is less than 5, just like I had there. Okay, and that is the paper done. So I'll just write 3 is less than k is less than 5 for my final answer. Okay, enjoy the rest of the weekend.